Hi guys, good night everybody. Just let me know if you guys can hear me before I start, please. All right, great. All right. So this is just a last minute exam preparation session for some of you guys who have been requesting this, right? My normal exam preparation lasts 4 months actually, right? Usually from January to May, that's my exam preparation period, right? I know a lot of people requested to come to the class, but it would have been a little too late, right? Um, so let's have a look at some examination questions here, right? All right, so a student is provided with two solutions, X and Y. X is aqueous sulfuric acid containing 4.9 gram per dm cube. So remember, the first question in your exam paper is typically 25 marks, right? And what I would suggest is that you start with that question first and do not spend more than half an hour on that question, right? So when you get a question and it seems very wordy, what I suggest you do is to read through the question and try to underline or make little notes if you need to try to understand what's happening here. So we have X and Y, but X is sulfuric acid containing 4.9 gram per dm cube. Then we have Y is sodium hydroxide. So we have two things here. We have sulfuric acid, which is H2SO4, right? We also have Y, which is sodium hydroxide, right? And right, so sodium hydroxide was prepared by dissolving 5 grams of impure sodium hydroxide in 1 dm cube, right? So basically what they're trying to say is here what? You see that sodium hydroxide we made up there? We had a container, right? And we had 1000 cm cube or 1 dm cube, right? And what we did, we added 5 grams of impure sodium hydroxide, right? 5 grams NaOH, and they're telling us that it is impure, right? The student titrates X against, so when you're reading these questions, try to make sure you understand what is what, right? So in this case, it titrates an X against 25 cm cube of Y in order to determine the purity of the sodium hydroxide, right? So that means that X is your sulfuric acid, right? So all of these, figure 1 below shows the readings on the burette before and after each titration against 25 cm cube of Y. So therefore, what you have here in the titrations here, that is the let's see, this one is the sulfuric acid, right? That's the sulfuric acid here, right? So the first thing that they want in this question here, right? The first thing they said in the space below, construct a table, right, to record the titration results, and you should include the initial and final burette volumes and the volume of X to be used in the, right? So let me change this to X here. So first things first, and let me see if you all know how to read off a burette here. I want you all to read off my final burette reading for the first titration. So this is the first titration here. This is your first titration. And I want you all to read off the final burette reading, right? Let me see what you all say. And I want to see how you're going to write it too, Right? Honestly, I'm not sure what year this paper is, right? I've selected papers from over the years, so. All right, I've seen people saying 25.5, some people saying 25.50. Let me give you a piece of advice here, right? Let me give you a piece of advice. Whenever you're writing on your burette readings, they should always be given to 2 decimal places, right? So this final reading here, right? This final titration reading here looks to me like 25.50. So what you're going to do, you're going to put that. You're going to say 25.50, right? Don't just put 25.5, Make sure you put it to 2 decimal places. Next thing we want now, we want the final burette reading. So let's go back to, sorry, the initial, right? The initial. Just give me what this reading here is. What is that reading there? No, this is not January 2. This is an older paper. This is an older paper. Right? I've done most of the recent papers in my online class. So that's why I'm using some different questions here. All right? I've seen people saying 0.50. I agree. That looks like 0.50 to me. right? So this here is 0.50, right? So that's titration 1. Now we can perform the subtraction one time, in which case you're going to get 25.00, right? So that's titration 1. Let's go to titration 2, and I want you all to read off this one here for me. What is the final burette reading for titration 2? Right, I've seen people saying 37.30, right? I think they're looking right. So let's see, 37.1, 37.2. Just remember you're reading the bottom of the meniscus, right? So that's 37.30. Don't just put 37.3, put 37.30, right? Next one now, we want the final burette reading, sorry, the initial for titration 2. This one here. What is that reading there? Right, I've seen 12.20, right? Yep, that's fine. Right, so when we do the subtraction here, we're going to get 25.10. Right, let's go to the third titration now. That's this one. I want the final. What's the end or the final titration reading here? All right, a lot of people saying 40.50, right? So this, yes, is 40.50. I agree with that. Right, and what is the initial? What's the start one here? So some of you all, I'm surprised some of you all getting it correct, right? A lot of people. So if you look at it carefully, right, and what you need to do in the real exam, right, and this is what I suggest you do in the real exam. If you have to read off some burette readings, right, what you should do is to take a ruler, right? Take a ruler and just go, and we're gonna read off the bottom of this thing here. Now, if I put this horizontal line here, you're gonna realize it actually not on a marker, right? It's between between 15.4 and 15.5. So that reading there is actually 15.45, right? 15.45, right? So this here is 15.45, right? Now, if you all get a table like this in the exam, you should be jumping for joy, because this is easy marks here, right? So 40.50 minus 15.45, and you're going to get 25.05, right? So 25.05, right? Sometimes in the exam, we get as much as 9 marks for filling out a table like this, right? So it's 3 marks if you know how to read off a burette reading, right? Now, that is part 1. Part 2 of the question says, what is the volume of X to be used in the calculation? So whenever you do a titration, right, we're looking at these values here, right? Now, I know in some schools, some teachers tell you just add up all and divide by 3, but that's not what you do, right? What you need to do, you need to look at your values, and you're only choosing values that differ, right, by 0.1, right, cm3, right? That's what you do. You're looking for values that differ by 0.1. So this first one here is 25.0. The next one is 25.10. So they're kind of close, right? They only differ by 0.1. And this one here is close as well. This differs by 0.05. So in this scenario here, what I would do, I would use all 3 of them in order to calculate my average value to be used in the calculation. So what you would do here is say 25.00 plus 25.10 plus 25.05, right? And you're going to divide all of that by 3. But I just want you to know that that is not what we do all the time. You need to actually look at the values. sometimes the rough titration might be off by about 1 cm cube. You can't use that, right? So let's average this now. So 25 plus 25.1 plus 25.05 divided by 3. And we're going to get 25.05. Right, cm cube. So that's the volume of acid that we're going to use in the calculation. The third part, calculate the concentration of the sulfuric acid in mole per dm cube. Now the sulfuric acid in the question, they told us it was 4.9, look it's here, 4.9 gram per dm cube, and they want to convert that to mole per dm cube. So we have 4.9 gram per dm cube, and we want to convert that into mole per dm cube, right? Now this is a very straightforward calculation, you know. All we need to do, we need to take sulfuric acid, that's H2SO4, right? And we're going to use the masses that they give us here, and we're going to work out the molar mass of sulfuric acid. So you have 2 hydrogen, so that's going to be 2 by 1, right? Plus we have 1 sulfur, so sulfur is 32, right? Plus we have 4 oxygen, so that's 4 by 16, right? And that's going to give me a total of 4 by 16 plus 32 plus 2, and you're going to get 98, right? So that there is 98 gram per mole, right? So that means that 1 mole of sulfuric acid has a mass of 98 grams. So all I need to do, you see this grams here, I need to convert that into moles. So therefore, we can say that 98 grams, right, of your sulfuric acid is actually 1 mole. So therefore, we need to figure out for that 4.9. So 4.9 grams, right? So I normally, my online chemistry classes, I've never taught my students any particular formula. Once we have the proper statements, all the calculations basically involve cross multiplication, right? So we take in this number, multiply by this number, divided by this number here. So that's going to be 4.9 multiplied by 1 all over 98. And that's going to give me, so 4.9 divided by 98, and you're going to get 0.05. Right, so this is 0.05 moles, right? So what that means is that the concentration of the sulfuric acid, and whenever you want to write concentration, I notice sometimes CSEC writes it like this. In chemistry, if you put a square brackets around a reagent, that means concentration. So the concentration of sulfuric acid here is actually 0.05 mole per dm cube. Right, so what I've done here, I've converted this 4.9 into moles here. That's all I did, right? The next part, part 4, calculate the number of moles of sulfuric acid using the titration. Well, since you know the concentration of the sulfuric acid in mole per dm cube, this statement here tells me something, you know. That tells me in 1000 cm cube, right? And those of you who weaken moles, what you really need to know here is this. 1 dm cube is actually 1000 cm cube, right? So when they tell you the concentration of something, it means that in 1000 cm cube we have, so 1000 cm cube of H2SO4, right? That actually contains 0.05 moles, right? Therefore, now remember, we did a titration here and we worked out the average volume of the sulfuric acid, which is 25.05. So you're going to say 25.05 cm cube of H2SO4. Right? And again, like I told you all, I've never taught my class any formula, right? So we're going to take this number, multiply by this number here, and divide by this number here, right? So this is going to be 25.05 multiplied by 0.05, and you're going to divide that by 1000, right? And in this case here, that's going to give me, I'm going to write the answer here if it could fit. So 25.05 multiplied by 0.05 divided by 1000, right? Now the thing is, the numbers are usually small here. So what I'm going to do, I'm going to put it as 0.00125, right? It's a lot more numbers here, 2 more numbers, but I'm just going to put this here. So that's the number of moles I have in that 25.05 0.05 cm cube. Yeah, so some of these calculations, you're going to notice that some of them are just worth like 1 mark, right? That's because they consider this calculation to be rather simple, right? And one of the things that you need to remember when you're doing these calculations, and let's say they have many parts, usually we need the answer from the previous part in order to work the current part, right? So all the answers tend to flow from one part to the next, right? Next part, they want us to write a balance equation for the reaction between sulfuric acid and sodium hydroxide. So sodium hydroxide, right? Now, when you are given or when you are asked to write an equation, sometimes you might see 2 marks, sometimes you might see 3 marks, right? So normally, if they ask you for an equation, it could just be 1 mark, and in order to get that 1 mark, you must have the formula for every single thing correct to get the 1 mark. If they tell you to balance it, and you balance it correctly, you're going to get 2 marks. If they ask you for state symbols, then the question is worth 3 marks. And when I say state symbols, I mean like you need to put aqueous, you need to put solid, you need to put gas, you get marks for that. So in this case here, I'm going to put the state symbols either way. So sodium hydroxide, aqueous, plus sulfuric acid. Aqueous, right? So you're taking an acid and you're reacting that with a base, right? So therefore we expect to get a salt and we expect to get water being produced. Now our assumption here is that we're going to get a normal salt. So those of you who are prepped and ready for the exam, you should know that there are 2 kinds of salts. There's something called a normal salt and something called an acid salt, right? So I'm going to assume it's a normal salt, right? Right? So let's see. So in this case here, it is going to be a normal salt. Let's assume sodium sulfate. That's at Na2SO4, right? Aqueous, right? Plus, we expect to get water as a product. So H2O liquid. Now, whenever you're given a question like this, we need to balance the equation, right? So let's see. If I put a 2 in front of the sodium hydroxide, will it be balanced? 2 sodium on the left, 2 sodium on the right. All right. On the left, we have 4 and 2, 6 oxygen. On the right-hand side, you only have 5. So therefore, I need to stick in a 2 here, more than likely. Right? So the oxygen is balanced, the sodium is balanced. Let's check the hydrogen. You have 2 and 2, 4 hydrogen on the left. And on the right, we have 4. So the hydrogen is okay. Then we have the sulfur. 1 sulfur on the left, 1 sulfur on the right. So this equation here is correct. That is a balanced equation for the reaction between sulfuric acid and sodium hydroxide. The next part now, part 6. Determine the number of moles of sodium hydroxide in 25 cm cube of solution used. Right? Now let's back up a sec here. Right? We need to read what's happening here. So the sodium hydroxide, right? The sodium hydroxide was the Y. So Y is sodium hydroxide, and you have 5 grams, right, dissolved in 1000 dm cube. And right, so each of the titration we use in 25 cm cube of solution Y or the sodium hydroxide, right? Now determine the number of moles of sodium hydroxide in 25 cm cube. So the reason why they made us write the equation is for us to use a mole ratio in order to figure out how much moles of sodium hydroxide we used. Now let's back up a sec here. So if you go back to this one here, this part 4 here, that was the number of moles of sulfuric acid used, right? Based on the mole ratio. So the mole ratio here is 2 moles of NaOH will react with 1 mole of sulfuric acid, right? 2 moles of NaOH reacts with 1 mole of sulfuric acid. So since you know from the previous part, the sulfuric acid is 0.00125. So let me just write that here. H2SO4. Right? The number of moles that we used was 0.00125. Right? And this thing reacting in a ratio of 2 to 1. Right? If you want to work out the sodium hydroxide, right, it'll be twice as much sodium hydroxide we need. Right? So then all we need to do, we need to say, all right, 2 multiplied by point, this is 5. 2 by 0.0125, right? And you're going to get 0.0025, right? Moles, right? So we had to use the equation using mole ratio to figure out how much moles of sodium hydroxide we had in 25. Next thing we want to do now, we want to calculate the concentration of the sodium hydroxide in gram per dm cube, right? So what we do know is that 25 cm cube, right, of NaOH, right, contains 0.0025 moles. So that's the number of moles of sodium hydroxide we have here, right? So therefore 1000 cm cube of NaOH contains, and again I'm going to cross multiply. This is going to be 1000 multiplied by 0.0025 all over 25, right? And that's going to give us 0.1. So I'm getting 0.1 moles, right? Now the question wants the concentration in gram per dm cube. That's what they want, right? So what we need to do, we need to find the molar mass of sodium hydroxide. So sodium hydroxide is 23 for sodium, plus oxygen is 16, plus 1 for hydrogen. I think that should give us 40, I believe. 23 plus 16 plus 1. So the molar mass of sodium hydroxide is 40 gram per mole, right? So all I need to do, you see this 0.1 here? I just need to convert that to grams. So 40 grams, so 1 mole, right? 1 mole is 40 grams, right? Therefore, 0.1 moles, right, is simply going to be 0.1 multiplied by 40 over 1. So that's going to be 4, right? That's going to be 4 grams. So therefore the concentration of the sodium hydroxide, which is what I want, right, is simply going to be 4 gram per dm cube, right? Is the answer here. That's the concentration of the sodium hydroxide in gram per dm cube, right? Right, so that's part 7. And the last part, calculate the percentage purity of the sodium hydroxide. Now, look how you're going to analyze this, right? Based on what reacted, the concentration of the sodium hydroxide, right? Based on the calculation we did, and based on the titration, you got 4 gram per dm cube, right? So that means you would have added 4 grams of sodium hydroxide to that 1 dm cube. But if you read at the beginning of the question, they told us that they dissolve 5 grams, right? They dissolve 5 grams of the impure sodium hydroxide to 1 dm cube. So therefore, right, that means that they added 5 grams, right? So that means that out of the 5 grams, only 4 grams will be actual sodium hydroxide. The remaining 1 gram is some kind of impurity here. So the percentage impurity, and some of you all may have done this as a lab in school. So it's really only 4 grams of actual sodium hydroxide divided by the total mass of the salt that they added. So it's 4 over 5 multiplied by 100%. And that's going to give us an 80% percentage purity, right? Now, question 1 could be based on many different things, right? It could be based on purity. It could be based on rates of reactions, because they love to bring rates of reactions, right? They love to bring rates of reactions, right? What else? All right, sometimes they bring electrolysis in question 1 as well, right? All right, so that's my first question here, right? My second one here now. So Steve places a zinc nail in a beaker containing copper 2 sulfate, right? So you have a zinc nail. This is zinc nail here. and you're placing that in aqueous copper 2 sulfate, right? Now this is a popular question that they like to bring, right? So copper 2 sulfate, you need to know the color of that. That is going to be a deep blue solution, and that is because of the presence of Cu2 plus ions, right? So this is the start of the experiment here, and then what happens after 3 days, right? They said the solution, you have a pale blue solution, you notice the zinc nail gets smaller, right? And then you get a shiny red brown solid, right? Based on the observed differences between figures 2A and 2B, name 2 ions that would most likely be present in the beaker after 3 days. You all feel you know the answer for this one here? What ions are present in the beaker after 3 days? Anybody? Right, I've seen some answers here. Some people saying, so here it is, when they ask you, so because I kind of have an idea of how students answer questions, right? You need to be very specific when you're answering these things. So you have a zinc nail, right? So initially, right, the only thing you had in the solution here would have been Cu2 plus, right? That's from the copper sulfate. You would have also had sulfate ions present, right? And well, because it's in solution, you would have had H plus and OH minus as well, right? But after now the 3 days, what's going to happen is that the zinc is going to go into solution, right? So you're going to get Zn2 plus. So that's what they're looking for here. That's one ion that's going to be present there, right? At the same time, you still, because the solution is still blue, you have Cu2 plus ions still present here, right? They just said name 2 ions that will most likely be present after 3 days, right? So when they say ions, please put the correct ions. Don't just say Zn, or don't say zinc, or don't say copper, right? Put Zn2 plus, put Cu2 plus. Now, write an ionic equation to show the reaction that takes place in the beaker and explain why these reactions occur, right? And then in part C, they said name the type of chemical reaction occurring, right? Does anybody know the answer for this one here? What type of chemical reaction is taking place there? When I put zinc in a solution of copper 2 sulfate. When I put zinc in a solution of copper 2 sulfate, what kind of chemical reaction is that? Alright, so a lot of people getting it correct. People telling me it's a displacement reaction. I agree. I fully agree with that. It's a displacement reaction. So this here is a displacement reaction. Right? Now here's what you all need to know, right? This question is based on metals here, right? You all need to know your order of your reactivity series, right? So you need to learn this off somehow, right? Right? So make sure you know the order of the reactivity series. So reactivity decreases as you go down the series. Potassium is the most reactive, right? Now in this experiment here, you are taking zinc and you're reacting that zinc with a solution of copper 2 sulfate. All you all need to remember here is that metals high up in the reactivity series are able to displace metals lower down in the reactivity series. So this zinc here is actually more reactive than copper. So therefore, if I take that zinc nail and I place it in a solution of copper 2 sulfate, what's going to happen is that the zinc is going to displace that copper, right? So the zinc is going to displace the copper. So they want an ionic equation. So let me just show you a little trick that I normally do. When they want an ionic equation, the first thing I normally do, I will write the equation for what is actually happening first of all. So you added zinc solid, right, plus a solution of copper 2 sulfate, that's CuSO4 aqueous, right? And that's going to produce, because it's a displacement reaction, the zinc is going to go into solution. So you're going to get ZnSO4, right, aqueous. So the zinc is going into solution, plus copper is going to be is going to come out of the solution as copper solid, right? That's what you're going to get. So the first thing I normally do, I will write the equation first of all, then I'll check to see is the equation balanced, right? Based on what I'm seeing here, the equation looks balanced. And then the next thing to do, you need to remove any spectator ions, right? Now, this sulfate here exists as SO42 minus, right? SO42 minus on the left-hand side. This sulfate on the right-hand side also exists as SO42 minus. Therefore, chemically, nothing is happening to it. So what I need to do, I need to remove this from my equation. That's a spectator ion, right? So the ionic equation that CSEC is looking for here is going to be Zn solid, right, plus Cu2 plus, right, Cu2 plus aqueous, right, that's on the copper sulfate, and that's going to give us Zn2 plus, right, aqueous plus Cu solid, right? This is what they're looking for, right? But I normally write the equation first and then I remove the spectator ions. So this here is the correct answer, this one here, right? And they want the explanation here. All you need to do is to tell them that zinc, Zn is above Cu in the reactivity series, right, and will displace the copper, right? That's essentially what we need to say here in order to get the marks, right? So let's go back to this here. So the reason why the size of the nail got smaller is because the Zn solid turns into Zn2 plus. The reason why the solution turns to pale blue is because you are removing Cu2 plus from the solution, right? So these are questions that they typically ask in this particular reaction, right? You get a shiny reddish brown solid. That shiny reddish brown solid here is copper solid. Sometimes in the exam you might hear them use a pinkish solid. That's copper they're talking about here, right? That's copper they're talking about. So this is a displacement reaction and you all need to know your reactivity series, right? Now they said comment on the rate of reaction, right? On how the rate of reaction might be affected, right? Let me make this a little bigger, hold on. Right? Comment on the rate of reaction. So they put this in caps here. So they're only focusing on the rate of the reaction, right? Is affected if the zinc nail is replaced by each of the following, right? We have magnesium metal and we have lead. So again, when it comes to rate of reaction here, they're talking about the reactivity series again, right? So I'm just going to write it back again here. You all need to know this for the exam, right? Right? Now, we started off with a zinc nail, so zinc is here, right? Zinc is here, right? So that's the position in the reactivity series. Now they tell us we want to put magnesium, right? If I use magnesium instead of zinc, how is that going to affect the rate of reaction? What do you all think? How is that going to affect the rate of reaction? All right, people say faster. I agree. It is going to be faster. The rate of reaction is going to be faster. So observation, faster rate of reaction, right? It's going to be a faster rate of reaction, right? It's a faster rate of reaction. And why? It is because look at where magnesium is. Magnesium is higher in the reactivity series. So all we need to say here is magnesium, right, is more reactive than zinc. Right? That's all we need to say here. Right? You notice they're giving you plenty marks for this here, guys. Alright, so now we want to use lead. If we use lead now, what you think is going to happen? What are we going to say for that part? right? So people say, right, some people say little or no reaction or slower reaction, right? So what we're going to say here is, now the thing is, lead is still above copper, so we expect a reaction to take place. It just means that the reaction is going to be slower, right? So you're going to say slower reaction, right? And in this case here, the explanation is that lead is less reactive right, than zinc. Right, so that's all we need to say here, right? So 6 marks for that, right? There's the next question here, right? So just remember, guys, don't forget, please hit like and please hit subscribe, right? I know a lot of you all are waiting on the chemistry channel. I'm trying to consolidate and try to manage one YouTube channel rather than multiple, right? So any new material will be on this channel here, right? I'll eventually change the name of the channel, right, to reflect exactly what I do. Right, so this question here now, right, this question here. Laurie conducts an experiment to investigate how the mass of a catalyst, manganese 4 oxide or manganese dioxide, affects the rate of reaction or rate of production of oxygen during the decomposition of hydrogen peroxide. Water and heat are also produced during the decomposition. Name 3 factors other than catalysts, right? I see a lot of people already started answer in the chat here, right? So they want 3 of them. So you need to know your factors that affect rate. So in this case here, we can see temperature, right? Temperature, concentration, right? We have particle size, right? You only want 3, right? Now, I know some people are going to say pressure, right? But you only say pressure when the reagents are gases, right? So for me, I will try to avoid pressure as much as I can, right? Because pressure is equivalent to concentration when it comes to gases, right? So we have temperature, concentration, particle size, right? The next part here, they want a balance equation to show the decomposition of hydrogen peroxide by manganese 4 oxide. By the way, if you do get an exam question where they ask you to describe how to prepare oxygen gas in the lab, it's basically the decomposition of hydrogen peroxide. So hydrogen peroxide has a formula given by H2O2 aqueous, right? And that decomposes very quickly when you add manganese dioxide, right? So we're going to get 2 products here. You're going to get H2O liquid. And if you're not sure, read the question carefully. They said water is produced. So therefore, we should get water. And in the experiment, you're producing oxygen gas, right? So this is what your reaction should be. I don't think it balanced. Let's see. If I put a 2 here, and I put a 2 here, it should be balanced. Now, we have 4 hydrogen on the left, 4 hydrogen on the right. We have 4 oxygen on the left, and we have 2 and 2, 4. Yeah, we're good, right? So this is your balanced chemical equation for the production or the decomposition of hydrogen peroxide, right? Let's see what else they want here. Figure 4 on page 11 shows the rate of decomposition of hydrogen peroxide as a plot of grams of oxygen liberated per second against the mass of catalyst for both 0.4 and 0.8 mole per dm cube of hydrogen peroxide, right? Now try to fit the graph inside here, right? But the graph is so big, right? I don't know if you can see it properly, right? So let me just tell you what here. I know you may not be seeing it properly here. So on this axis here, you have mass of the catalyst in grams. Across here, we have the rate, right? As the rate of oxygen gas being produced, right? Now, we have 2 graphs here. This graph here, right? I barely seen it too. But this graph here shows hydrogen peroxide of concentration 0.80 mole per dm cube, right? That's the concentration of the hydrogen peroxide there. But what they're doing, that straight line there, they've changed the mass of the catalyst and measured the rate of reaction, right? This is also another experiment here, but this time they use a different concentration. They use 0.40 mole per dm cube, right, of hydrogen peroxide. So therefore we have two graphs with two separate concentration of hydrogen peroxide. Now the first part of the question says, explain why the plots in figure 4 are different. Why are the plots different? You have two graphs here, two straight line graphs here. One has a concentration of the peroxide being 0.4, and the second one has a concentration of the peroxide being 0.8. What's the difference? Why are the two graphs different? Why you all think so? Alright, I can ask chemistry chat. Guys, if you all want to pass chemistry, right, all you all need to do is, if you have to study something for the exam, make sure you learn the whole of organic chemistry, right? It is what I normally tell my class to do. Learn the whole of organic chemistry. Do not listen to what people say. Organic chemistry is the easiest section of the entire syllabus, and all of the questions are predictable. Question 3 and question 5 in your exam is going to be based on organic chemistry. That's a total of 30 marks, right? So if you want to spend time studying something, make sure you know your organic chemistry very well in order to answer that exam tomorrow, right? Yes, study organic chemistry. I have done organic chemistry 3 times with my class that is going to write that exam tomorrow, right? So I don't make joke with organic chem, and you shouldn't make joke with that either. That's 30 marks in the exam, right? All right, so let me see what people are saying here. People are saying the concentration different, particle, right? So let's see. So in this case here, right? In this case here, they said explain why the plots are different, right? So all you're gonna say here is that since the concentration of the hydrogen peroxide is different, the rate is different, right? Now this is 2 marks here, and always pay attention to how much marks for a question, right? So since the concentration of the peroxide is different, the rate is different, right? If you just say this alone here, you'll only get 1 mark, right? If you look at it carefully, let's go back to the graph. You will notice that this one here is a higher concentration than this one here. So therefore you notice that the values or the graph itself is above. So therefore the higher the concentration, the faster the rate, right? So you're going to say that. You're going to say the 0.8. Is it 0.8? 0.8. So you're going to say the 0.8 0 mole per dm cube H2O2 gives a faster rate. Right? Always pay attention to the number of marks being given for a question. That's a guide in terms of what is required. Right? So that's it. That's the answer for that part. The next one, for the 0.8 mole per dm cube, right, and 4 grams of catalyst, determine the following. Right? The volume of oxygen produced in 16 seconds. Now let's go back to this thing here. Right? So we're looking at the steeper graph, right? And we're looking for how much? 4 grams. Right? So let's go back here, make sure we answer it properly. So we're looking at the straight line that has the 0.8, sorry, and we're looking for 4 grams of the catalyst. So we go here. So 4 grams of the catalyst is this, right? When I go up to the graph here, now since we're going to use the line of best fit, right? I'm not using the points that they plotted, and the rate here is going to be 0.0050, right? So let's write down that. The rate is 0.0050. So the rate is 0.0050. All right, let's check something here. Right, I just wanted to see, so that's grams of O2 per second, right? Grams of O2 per second. So this is grams O2 per second. right? Now, that is a reading from the graph, but that's not the answer to the question, because the question says the quantity of oxygen, right, produced in 16 seconds. So since you know that the rate is 0.005, and that's per second, right? So therefore, all I need to do to work out the volume, right? Well, the quantity, because they're dealing in grams here, right? All I need to do is to take the 0.0050 and you need to multiply by 16, right? Because in 1 second you produce 0.05, so therefore for 16 seconds you have to multiply by 0.005, right? And you're going to get 0.08 grams of oxygen gas, right? So we took the rate and you multiplied by the time here, which is 16 seconds. Part B, we want to work out the number of moles of O2 produced in 16 seconds, right? Now the mass of oxygen is 16, so therefore for O2, right, that's 2 oxygen atoms, so that's going to be 2 by 16, so that's 32. So therefore 32 grams, right, is 1 mole. So you're going to say that 32 grams of O2 is 1 mole. So therefore, if I want to work out 4.08 O2, right, again you're going to cross multiply, so that's 0.08 by 1 all over 32, right, and that's going to give you 0.0025, right? That's the answer for that part there, right? That's the amount of moles of oxygen present in this thing, right? Right, I kind of just glimpse in the chat here. Yes, in the exam, do not leave any question blank, right? I see some people mentioning green chemistry. That's something you're going to read through tonight and probably read through tomorrow just before you go in the exam, right? Question 6 is, it could come as an easy question, or it could come as a hard question, right? Right, the last part here, okay, I thought they were going to ask this. So they said, what is the volume of oxygen gas produced at STP? So that's standard temperature and pressure. So what we know here is that 1 mole of a gas, so 1 mole of O2 gas at STP, right? They tell us it here, so we don't need to learn this off here, right? That is actually 22.4 dm cube. Right? And what we want to work out here in the previous part. So pay attention to some of these questions. Normally the calculations, they follow each other. So you worked out 0.0025 moles. So this is going to be 0.0025 moles O2, right, at STP. Right? Again, you're going to cross multiply. So it's going to be 0.0025 multiplied by 22.4, right, all over 1, and that's going to give us 0.056 dm cube, right? If you want to multiply that, or if you want to convert that to cm cube, you multiply by 1000, and that's 56 cm cube, right? So that's the volume of oxygen gas produced there. Right. So those of you who are not strong in organic chem, right? I have tons of videos on organic chem, right? If you go through those videos there, it covers basically everything that is required for the exam, right? Part C here, draw a fully labeled energy profile diagram to illustrate how the catalyst affects the rate of decomposition of hydrogen peroxide. Now you guys need to know how to draw energy profile diagrams, right? Now the thing is, if you want to show the effect of a catalyst, right, you first need to know, is this reaction going to be endothermic or exothermic? Now if you go back to the question, they did mention something about this, right? They said something about heat and water. So they said in this reaction, water and heat are produced. So if heat is produced, what kind of chemical reaction is that? Could you guys tell me, is it endothermic or exothermic? All right, people saying exothermic, excellent. That's what it is. It's exothermic, right? So it's an exothermic reaction, right? Now, when it comes to an exothermic reaction, now you all need to be able to draw your energy profile diagrams, right? So this here is energy, right? And here, now I don't want, please don't put time here, right? Do not put time here, right? You're gonna get penalized for putting time there, right? You're gonna put progress of reaction. That's what you're gonna put. So progress of reaction, right? Now, it's an exothermic reaction. In an exothermic reaction, energy is released. So when I'm drawing a diagram like this, what I need to do, I need to put the position of the reactants and the products. So if it's an exothermic reaction, you are giving up energy or you're giving out energy, right? So therefore, I expect the product to be less than the reactant. So the first step in this process here is I'm going to put your reactant here. And because it's an exothermic reaction, you're going to come here to write your product. Now, you can actually write the word reactant and product, but in this case, we know what we're dealing with. We're starting off with hydrogen peroxide, right? And then what we getting as the products here, we getting water and oxygen, right? So you can put that in your diagram if you want, or you can just put the word reactant and put product. So that's step one. You put those levels first. Next thing you're going to do now, you're going to draw this hump here, right? So you're going to draw this, right? Now on a diagram like this, you have to be able to label what is, I'm going to label everything for you guys here. So the first things first, the difference between the energy content of your product and your reactant, this here is referred to as your delta H, right? Or your enthalpy change, right? Now, here's what's going to happen here. This height here, right? This height here is what we call our activation energy. So this here is your activation energy. Right? Now, that's the activation energy there. But the question is asking me to show how the catalyst affects this. Now, what a catalyst does, right? What a catalyst does, it lowers the activation energy. So instead of going that high, this is what happens. Right? You end up back at the same spot, but your activation energy has been lowered. So you see this green arrow here? So this here is the activation energy, right? But this here is with the catalyst. Right? That's with the catalyst, and the one before, right? The one before is the activation energy without the catalyst. Right? So you all need to be able to draw an energy profile diagram like this in the exam, right? One of the things that you need to know as well, for an exothermic reaction, your delta H is actually negative, right? That's for an exothermic reaction. So while I'm here one time, we have two kinds of chemical reactions. We have something called endothermic reaction and exothermic reaction. If I had, let's say a test tube, and I had an exothermic reaction taking place, what's going to happen is that energy is going to be released to the surroundings. So if you hold the test tube, it's going to feel hot, right? So that's an exothermic reaction. For an endothermic reaction, energy is absorbed from the surroundings. So therefore, if I hold the test tube, it's going to feel cold, right? So you need to know the difference between endothermic and exothermic, right? Another thing you need to be able to know as well is that whenever you have a chemical reaction taking place, we have bonds being broken and we have bonds being formed. The bond breaking process requires energy, and because it requires energy, it's an endothermic reaction, right? So for bond breaking, you need energy. That's an endothermic reaction. Every time you form a bond though, you get an exothermic reaction. Right? Energy is released when a bond is formed. right? Now, in any chemical reaction, you're going to have bonds breaking and bonds forming. If you form more bonds than you break bonds, then the overall reaction is going to be exothermic, right? So these are questions that come in the exam. You all have to be able to explain why a reaction could be endothermic or exothermic. And it has to do with the number of bonds being broken and the number of bonds being formed. When you break bonds, you require energy. That's an endothermic process. When you form bonds, energy is released. That's an exothermic process, right? So you need to be able to explain this, right? Let's see what else we have here. Right, we have our next question here. We have chlorine has two isotopic forms, chlorine 35, chlorine 37. Chlorine has atomic number 17. What differences are expected between chemical reactions of chlorine 35 and 37? Right, now this is a nice question here. So just for your knowledge, right, chlorine has two isotopes. We have chlorine 35, 17. And we also have chlorine 3770, right? Now the question is, what differences, if any, are expected between the chemical reactions of chlorine 35 and chlorine 37? Anybody know the answer for this? So I've seen some people from my chemistry class inside here, right? Let me look at the answers here, Ian. Right, I've seen some people say chemistry is the hardest subjects, right? So last year in my class, 52 of my students got grade 1s. Right? Last year, 52 students got grade 1s in my class. Right? I know some of you all wondering, shucks, I should have go to this man class, right? All right, so let me answer this question for you all, right? Let me answer this question to you all. So the answer for this is, they said, what difference is? None, right? The answer is none, no difference, right? Let me tell you all something, right? When it comes to chemical, they said chemical reactions. Chemical reactions are determined by your atomic number, right? Chemical reactions are determined by your atomic number. Chlorine 35 and chlorine 37 have the same atomic number. They are the same element. So therefore, the chemical reactions will be exactly the same. What is different though is their mass numbers. You see mass number? Mass number affects your physical properties. So chlorine 35 and chlorine 37 may have slightly different physical properties, but their chemical properties exactly the same, right? So all you need to say, there are no difference, right? Atomic number is the same. So if you all never saw this before, you learn something new. So atomic number is the same, right? And therefore similar chemical properties, right? Or in this case here, they call it chemical reactions, right? Now, next part here, determine the number of electrons, protons, neutrons in the anion formed from chlorine 35. So we have chlorine 37, right? So for this one here, how many electrons do we have in chlorine 37? Read the question carefully before you answer. Qualitative, I have my doubts you're going to get anything on qualitative, right? I mean, even if it does come, chances are they will probably ask us to test for a gas or something, right? So you all didn't read the question properly, right? So here's what's happening here. The question says, in the anion. Read that carefully. So what that means is that chlorine has turned into Cl minus, right? So it's turned into Cl minus. If you want to turn into Cl minus, right, what happens is that we're going to gain 1 electron, So therefore, you should have 18 as your answer, not 17, right? A lot of people put 17 here, but it's going to be 18. They said the anion, so that's Cl minus or the chloride ion, right? What about number of protons? What's the answer for this one here? How many protons do we have in this anion? How many protons do we have? Right, so this one, I assume you all say any correct answer in this case here. So the proton number will not change, so that's going to be 17. That's not affected. And what about neutrons? How many neutrons we have there? How many neutrons do we have? Right, people saying 20. Yeah, so to get the number of neutrons, we take the mass number, which is 37 minus 17, and you're going to get 20. Right, that's the correct answer. Right, so read your questions carefully. You don't want to lose marks silly in the exam. Right, so that's part A. Explain the term ionic crystal. Right, explain the term ionic crystal. Right, so I know some of you all mightn't be able to type anything in the chat here. Right, but an ionic crystal, basically, you have the word ionic inside it. So basically, it's ions, right, arranged in a regular repeating pattern. That's what we're looking for here, right? In a regular repeating pattern, right? So one of the ions or the crystals that we have to learn for the exam is sodium chloride, right? We have to be able to draw sodium chloride, right? Now sodium chloride has cubic lattice, right? So in the second part here, they said using the symbols are solid, right, for sodium ions, and this solid with lines on it for chloride ions. Fill in on the diagram the positions occupied by these ions in the sodium chloride, right? So they kind of give us part of a structure, right? Not the whole thing, right? So all I would do in a case like this, I would probably put, let's say this is sodium, right? So therefore here should be a chloride, sorry. Here is going to be a chloride. This is going to be a sodium, right? This down here is going to be a chloride, right? And this here is a sodium, right? This here is going to be a chloride, right? Sodium again, right? So this is a partial structure here, right? Now when it comes to the structure of sodium chloride, it's a cubic lattice. And one of the key features here is that each Na plus, right? Each Na plus is surrounded by 6 Cl minus, right? And vice versa. So whenever you're drawing a diagram, this is what they're really looking for. They're looking to see that you could identify that we have one sodium ion surrounded by 6, right? Let's see what else we have here now. The melting point of chlorine, sodium chloride, and magnesium oxide are -101, 800 and 2800 respectively, right? So there are two things we're talking about here. Chlorine, when they say chlorine, they're talking about chlorine gas. They're talking about sodium chloride, that's NaCl, and they're talking about magnesium oxide, right? So they're telling us that this melting point here is -101 degrees Celsius, sodium chloride is 800 degrees Celsius, and this next one here is 2800 degrees Celsius. Right, so those are my melting points. Now the question says, explain why the melting point of sodium chloride is much higher than chlorine. Look at the marks, eh? Why is the melting point of sodium chloride much higher than chlorine? Right? Now this is not you're not in my live class here, so I can't just say, hey, tell me the answer, right? So what you all think is the answer for this though? If you could write it. Right, let's see what's happening here. Ionic bond, I see people saying about ionic bond, right? Some people say van der Waals are seen being mentioned here, right? Now, when it comes to explaining your answers, you need to be crystal clear in terms of what you say, right? So based on the numbers, we can tell that sodium chloride has a higher melting point. We can see that, right? So all you're going to say is that sodium chloride has a higher melting point, right? Because you're going to tell them why. So sodium chloride is an ionic compound. So because of the strong electrostatic forces, right? Or you can say ionic bonds. So you can say ionic bonds or strong electrostatic forces. Right? Or you can put ionic bonds. Right? So that's the reason why the sodium chloride has a high melting point. Right? In the case of the chlorine now, right, you can say Cl2 has a lower melting point. Right? Because of the weak van der Waals forces. Right? Van der Waals forces, or we will even accept intermolecular forces. Right? Between the molecules. Right? So when you are explaining your answer, you need, like I said, you need to be crystal clear in terms of what you're saying. So in ionic compounds, we have strong electrostatic forces. So therefore, you need a lot of energy in order to separate the ions. Therefore, high melting point. Right? When it comes to something like chlorine gas, you have weak intermolecular forces between the molecules. So therefore, it requires less energy in order to separate. Right? So therefore, that's why we have a lower melting point. Right? All right, next part here. The crystal of magnesium oxide and sodium chloride are similar. So the reason why sodium chloride and magnesium oxide are similar is because sodium chloride is ionic, right? Sodium chloride is actually Na+, right, combined with Cl-. In the case of the magnesium oxide, you have Mg2+, right, and you have O2-, right? Now the question says, suggest why the melting point of magnesium oxide is much higher than that of sodium chloride. Why you all think magnesium oxide has a much higher melting point than sodium chloride? I've seen some real good answers in the chat here, right? I don't know who is John Ditsen, right? Sodium chloride has strong bonds, require a large amount of energy, right? So you all are writing out your answers properly, right? Magnesium oxide has both magnesium. Alright, so I don't know who is Josh and John. You are writing out some excellent answers here. So you are looking like you're going to pull off a 1 tomorrow, right? Right, Iran as well. I've seen his answer there. Doubly charged. Yeah, so you all saying the correct answer, right? I'm not sure why. You all need to subscribe. Maybe that's why. I'm not sure. Alright, if you can't post a message, it means you probably need to subscribe. That's why. Right, so here's what we're gonna have here, right? So some of you all had some excellent answers in the chat, right? So what's happening here is that in the magnesium oxide, right, there are doubly charged ions. And when I say doubly charged ions, I'm talking about you have Mg2+ and you have O2-, right? Therefore, right, the electrostatic forces are much stronger than in NaCl. Right? That's all you need to say here in order to get that mark. Right? All right, let's see what else I have here. Okay, so I have 4 organic compounds here, right? Like I said, you want to pass the exam, make sure you study organic chem, right? 30 marks out of the 100 marks will be based on organic, right? So we have which compounds belong to the same homologous series? Which compounds belong to the same homologous series? What do you all think is the answer for that? We have compound A, B, C, and D. Which ones belong to the same homologous series? Alright, I've seen some answers in the chat here. For those of you who can't send anything in the chat, right? Chances are you need to subscribe to the channel before you could send a message, right? So we need to look at these compounds here. So compound A, we have the COH bond here. In compound C, you have the COH bond here. Now don't get fooled by this here. This here is a different structure here. So compound B is a different structure. So the 2 compounds which belong to the same homologous series will be A and C, right? In the second part here, they said state the homologous series, right? And give a reason for placing them in the same series. So what series does A and C belong to? In what series does A and C belong to? Right, I've seen both people saying both are alcohols. I totally agree with you guys, right? So it's the alcohol homologous series, right? Alcohol homologous series. Right, that's the answer for that. Now they said give a reason for placing them in the alcohol homologous series, right? All you're going to tell them is that each has the hydroxyl group, right? So each of them have the hydroxyl group, which the hydroxyl group, by the way, is ROH, right? That's the hydroxyl group. Sometimes they ask us to name the functional group, right? So that's part 2. The next part, draw the fully displayed structures of any 2 structural isomers of compound C. So what is compound C now? So compound C, let me ask this first. Could you guys put in the chat for me what's the name of compound C? What is the name of compound C? Curious to see what you all say for this one here, right? I hope nobody from my class said the wrong thing here, right? I want to know what's the name of compound C. Aha, right? So those of you who've never seen this before, you're going to learn something now, right? So this compound here, compound C, has 1, 2, 3, 4, 5 carbons. So we know that because it has 5 carbons, it has pent in the need, right? Now the thing is, it's an alcohol. Now let me just show you something here. So a lot of people saying the compound is pentanol, right? Let me just tell you something here quickly. If you all put that for your answer, you will get it wrong, right? If you put that for your answer, you'll get it wrong. When it comes to alcohols, we need to identify exactly where the OH is. So the name of that compound is actually 1-pentanol, right? Or another name is pent and dash 1 dash all, right? These are the accepted answers here, right? So don't rush and put pentanol as the answer. You will not get it correct. It is 1-pentanol or pentan-1-ol, right? So keep that in mind. If you've never heard that before, that is how you name these compounds, right? So you have to be careful when you're naming an alcohol and when you're naming an alkene, right? Right, so I just asked you the name for so, right? So they want isomers. Now, as an exam question, right? As an exam question, you all need to know what is meant by a structural isomer, right? When it comes to an isomer, you have to know what is a structural isomer. Structural isomers, right, or structural isomers are organic compounds with the same molecular formula but different structural formula, right? That's an exam question that comes a lot. What is meant by a structural isomer? So, organic compounds with the same molecular formula but different structural formula. Another thing that they can ask you in the exam, guys, there are some definitions in organic chem. You all need to know what is meant by a hydrocarbon. A hydrocarbon is an organic compound that contains only carbon and hydrogen, right? So that's our next definition you need to know. So structural isomerism, you need to know what is meant by hydrocarbon. You also need to know what is meant by cracking. You all need to know what is cracking. We have two kinds of cracking, right? So let me just hold on. Let me show you something quickly. Right? So here's what you all need to know for the exam, right? There's some definitions that we need to know when it comes to organic, right? So you need to know what is meant by a hydrocarbon. Make sure you learn these definitions, right? Structural isomerism, right? You need to know what is meant by cracking. Well, let me break it up here. You need to know what is meant by thermal cracking. You also need to know what is meant by catalytic cracking. Right? You need to know your properties of a homologous series. Right? You also need to know what is a functional group. Right? What else we need to know here? I think that's... So those are some of the definitions that we need to know. So hydrocarbon, organic compound with only carbon and hydrogen present. Structural isomerism, organic compounds with the same molecular formula but different structural formula. Thermal cracking. So we have two kinds of cracking, thermal cracking and catalytic cracking. When it comes to thermal cracking, basically you take a long chain alkene and you apply heat, right? Any temperature above 450 degrees Celsius. And you're going to break it up into smaller alkenes and smaller alkenes. That's what it's going to be, right? That's the definition for thermal cracking. When it comes to catalytic cracking, you're starting with a long chain alkene, right? And what you're going to do, you're going to heat it in the presence of a catalyst, and then you're going to get a smaller alkene and alkene as well, right? So you need to make sure you know the difference between thermal cracking and catalytic cracking. Let's do functional group. Functional group is an atom or a group of atoms that determines the chemical properties of an organic compound, right? Okay, somebody mentioned something again here. Yes, you need to know what is a polymer. Yep, that's another exam question. So a polymer is basically a macromolecule made up of many repeating units called monomers. So those are definitions we need to know in organic. Let me see if anybody wrote anything else in the chat there. Right, so in terms of your properties now, right, there are about 5 or 6 properties that you all need to know. This is a very popular question that they like to bring. So, homologous series. First thing, they all have the same functional group, right? That's property 1. They all have similar chemical properties. That's property 2. Third property, physical properties vary with the number of carbon atoms, right? Next property, the adjacent members differ by CH2 units, right? And we have a next one here. They all have similar method by which we prepare them, right? So make sure you know at least 3 of your properties for your homologous series. Those are exam questions that they repeat over and over, right? So let me go back here now. We started talking about isomers, right? And we want to write isomers for 1-pentanol. Now, whenever you want to write or draw an isomer for an alcohol, your best option here is to change the position of the OH. That's the easiest option here. So for me, if I had to draw 2 isomers, because they want 2. 1, 2, 3, 4, 5. All I will do is put 1 OH here, right? 1, 2, 3, 4, 5. So let's complete the diagram, right? Don't leave any bonds hanging, right? Always complete your diagram. All organic chem question diagrams are 2 marks, and it's a very easy 2 marks if you know what you're doing, right? So this compound here is 2-pentanol. That's the name of this compound here because it's bonded to the 2nd carbon. So this here is 2-pentanol, right? That's an isomer, right? And for the next one here, well, I'll draw 3-pentanol, right? 1, 2, 3, 4, 5. Just put the OH here, right? Complete the diagram. Right, those of you looking for videos on the different topics for the exam or topics in chemistry in general, right? I have practically videos on practically the entire syllabus, right? You can find all the videos on my CSEC Maths channel here, right here, right? So you can use that if you want for practically any topic. This one here is 3-pentanol. Right? So if they ask you for isomers of an alcohol, just change the position of the OH. That's all you need to do. All right, so we have a question here now. We have reactions of compound E. Use the information in figure 4 to answer the questions. So they give us a diagram here, and they have different reactions taking place. So this here is ethene, right? Because it has a double bond, carbon to carbon double bond. They have glucose here, so that's sugar. And then they said reaction 2 here, so this is some yeast. Could you all put for me, right? They didn't tell us, they didn't ask us what is E, but I want to know what is E here, right? What is compound E here based on the diagram? Right? A lot of people saying ethanol. I agree. This is ethanol here. Right? This is ethanol. Right? And the reason why I'm saying that ethanol is because you started off with glucose and they have something like yeast here. Right? Now, the next part here for reaction 1, right? Reaction 1, you want to know what are the reagents and what are the conditions. So how do I convert ethanol into ethene? How do you convert ethanol into ethene? How do we do that? How do we convert ethanol into ethene? All right. So I've seen some correct answers here. So here's what. They want the reagents. So if you want to convert ethanol into ethene, we need concentrated sulfuric acid. I am telling you off the bat, if you just put sulfuric acid alone, you will not get the mark, right? If you want to convert ethanol into ethene, you need concentrated sulfuric acid. And I saw some people put 170 degrees. Don't just put high temperature, you know. If you all put that, you're not getting any marks for that, you know. Right? You're not getting any marks for that. You need to be specific with the temperature, right? So it is concentrated sulfuric acid and a temperature of about 170 degrees Celsius, right? And I seen you all saying what kind of reaction it is. They didn't ask us, but this is a dehydration reaction, right? This is a dehydration reaction, right? So this is a dehydration reaction here, right? See what else they want. So state the name of the process occurring in reaction 2. So reaction 2 here, what are they talking about? What happening here? What's the name of that process? All right, excellent job, guys. Everybody saying fermentation. I agree, it is fermentation taking place here. Right, now while I'm here, right, so fermentation, I'll talk about it one time. That's a question that can come for anywhere between 5 and 7 marks in the exam to describe the process of fermentation, right? Make sure you understand how to describe the process. So if you want to make wine or to make ethanol, what we do, we start with a sugary or starchy substance. So normally we need to give all the ingredients. So you need a sugary or starchy substance. So you can start with grapes, you can start with rice, right? Basically anything that has sugar in it or something that is starchy, you're going to take that, you're going to mix it with water, and you're going to mix that with yeast, right? You need yeast for the fermentation process, right? So you mix all of these things together and you leave it to ferment for a few days. You need to say that in your answer, you know. You need to say leave to ferment for a few days. What's going to happen is that the yeast, right, is going to break down the sugars, right, anaerobically. I am telling you what you're getting the marks for, right? So you need to say that the yeast breaks down the sugars anaerobically. You need to say what that is. That is without oxygen, right? It breaks down the sugar anaerobically to produce ethanol, right? When the concentration of the ethanol reaches about 14%, what happens is that the yeast, they become denatured. Do not go in the exam and tell them that you kill the yeast. That's not what happening, right? The yeast, they're still there, but they are denatured. That's the correct word we need to say. They stop working. That's what it means, right? So that's it. So you get some ethanol, right? You get some ethanol. And then what happens is that if you want to get a higher concentration of ethanol, then what we need to do simple distillation or fractional distillation in order to get a higher concentration of alcohol. All of those are exam questions to describe the process and to explain how can we get a higher concentration of ethanol, right? So that's fermentation. That can come as a 5 or 7 mark question. So this here is fermentation. Right? Next one here. Draw the correct formula for compounds E and F, and hence write a balance equation for reaction 3. So what do you want? Correct formula for E and F. What is E? What is F? So E is ethanol, and what is F? Oh, okay. So we taking ethanol, and in this third reaction here, we are burning it in ethanol. What's compound F? What are you talking about here? What is compound F? Right? People saying carbon dioxide. Yeah, I agree with that. Right? So let's see what they really want here though. They said draw the correct formula. So ethanol, I'm just going to draw ethanol, right? So this is ethanol here, right? So this is ethanol, and it's combustion we're talking about here. So plus O2, right? So when you have combustion taking place here, there are two products. You're going to get carbon dioxide, right? Plus H2. Those are the two products here, right? So the ethanol is C2H5, right? C2H5OH, right? Now, in terms of combustion here, right? Let's see what we need. If we put a 2 here, right? You need to get 6. So maybe you put a 3 here. Will that balance? 4 and 3 is 7. And we have 1 here. So this, right? So this is the balance chemical equation for what's happening here. Notice it's 3 marks here, right? So ethanol plus oxygen, there are two products. That's a combustion reaction. When it comes to ethanol, it burns with a clean blue flame. That's what it is, right? It's a good source of energy. That's why they use it in cars, right, as a fuel. Draw the full structural formula of the organic product that is formed when compound E reacts with compound B. Okay, what is E, what is B? So compound E is ethanol. Where is B? Oh, we got to go back to the beginning of the question, right? So compound B. Oh, So compound B is propanoic acid, right? Compound B is here. That's propanoic acid, and you want to react this thing here with ethanol, right? So propanoic acid, which is this, right? So you have propanoic acid here, and you want to react that with this here, ethanol. First thing I want from you all, I want to know what class of compound am I going to get? What class of compound am I going to get? Right? People saying ester, right? I agree. So what I normally tell my students, when you have to draw an ester, we always draw the acid part first. So it's propanoic acid. So you're going to put this here, right? And the next thing we're going to draw our ethanol on the right hand side here. So you're just going to put here 1 1, right? So the ethanol just has 2 carbon, and that's it, right? That's my ester that I'm going to get. Could you all put the name of the ester for me? What's the name of the ester that I've produced here? Right, I've seen a lot of correct answers, right? Some people give me some bogus answers here. So the name of this thing here, the name comes from, the first part of the name comes from the alcohol, and the second part comes from the acid. So because it's ethanol, it's going to be called ethyl, and the acid was propanoic acid, so it's ethyl propanoate, right? Ethyl propanoate. That's the name of the ester, right? Let me ask you all a question again. What conditions, if I wanted to make this ester in the lab, what conditions are required? That's an exam question. What conditions, right, are required? What conditions are required in order? Oh my God. I've seen some weird answers here, man. Let me look at people in my class, make sure you all have this correct. Let me see, I've seen Xavier inside here. Right, so Xavier has the correct answer, as well as some other people, right? If you want to make an ester, there are 2 conditions required. You need to, using concentrated sulfuric acid as your catalyst, Conc H2SO4, right? Catalyst. I see a lot of people saying UV light. Nope, 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 nope. Right, so this is a catalyst. Sometimes in the exam they ask you, what is the purpose of the concentrated sulfuric acid, right? If you just put H2SO4, you get 0. You must put concentrated. And we need to heat this under reflux. So heat under reflux. Right? That's the answer here. Those are the conditions required if you want to make an ester, right? All right, next thing here. I have a next question, right? Using only the elements indicated in table 3 to answer the question below, each element may be used once, more than once, or not at all. So they have a partial periodic table here, right? The first part, which element reacts most readily with dilute hydrochloric acid? What's the answer for A part 1? What's the answer for A part 1? Right, excellent. Everybody saying calcium. Yeah, right. So dilute acid will react with a metal, right? This here is actually group 2, right? So group 2, right? Calcium is going to be more reactive than beryllium. Next thing they want, a balance equation for the reaction. So calcium plus HCl, right? So you're adding a metal plus an acid. So you're going to get a salt. In this case, it's going to be calcium chloride, CaCl2, plus hydrogen gas, right? And in this case here, to balance, we're going to put a 2 here, right? So 2 marks for that. Next part, describe any differences that may be observed in the reaction indicated in A1 above if dilute sulfuric acid were used instead of hydrochloric acid. Aha, they're giving them 4 marks for this. So we're looking at this reaction here, right? If I take hydrochloric acid and I react it with calcium, I'm going to get calcium chloride and hydrogen gas. The question is asking me, describe any differences, right, that may be observed in the reaction if we use dilute sulfuric acid instead. I wonder if anybody know the answer for this. I know some of my students here, right? So somebody should know this answer. So we're using sulfuric acid instead of HCl, right? Instead of HCl. What? Aha. I've seen some people, at least one person saying the correct answer. Ah. Right, no problem. That guy who's gonna do engineering, right? That's no problem. All right, let me see what happened here. So, okay, so some people have the correct answer, not everybody, right? So, what happens here, right? So, calcium, right, plus sulfuric acid, H2SO4, right? We expect to get a salt and water. In this case, we're gonna get calcium sulfate, right? CaSO4 plus, hydrogen gas, right? H2 gas, right? The equation itself is already balanced, right? But what's happening here is this. You see this calcium sulfate that they produce here, right? So the calcium sulfate, right, is insoluble, right? Calcium sulfate is insoluble, right? It coats the calcium and the reaction stops. If you've never seen this before, this is something that's there in the syllabus, right? It coats the calcium and the reaction stops. Right? Now, what is happening here? So you have a piece of calcium, right? But when you start to react with the sulfuric acid, you're going to form calcium sulfate on the outside, right? So you have H2SO4 on the outside here, right? And it's trying to get to the calcium. But if you form this insoluble on the outside here, you have calcium sulfate, right? So therefore the sulfuric acid can't reach to get to the calcium. So the reaction stops, right? Right? What else we have here? Identify 2 different elements in table 3 which were combined by covalent bonding. They want 2 different elements. So look at the periodic table here and I want to know, give me 2 elements that can form, right, 2 different ones instead to form a covalent bond. There are more than one answer here though. They want 2 elements that can form a covalent bond, 2 different elements. Oh, guys, the question said 2 different, right? I've seen people put in, let me see, 2 different elements that can form a covalent bond, right? Right, I've seen a lot of answers here, so let me just give you what I would put. So carbon could combine with chlorine to give me CCl4, right? That compound is on the syllabus, right? I can also take silicon and react it with chlorine to give me SiCl4. That's a possibility. Phosphorus could react with chlorine to give me PCl3, or it can give me PCl5, right? So we're looking at compounds that can give us different things, right? So for me, I'd rush for this one here, carbon and chlorine, right? That would be my option, right? But they have more than one answers. So carbon and chlorine, right? Draw a dot and cross diagram to illustrate the bonding in B. So your carbon belongs to group 4. It has 4 valence electrons. Chlorine belongs to 7. You have 7 valence electrons. So if you want to draw a covalent a dot and cross diagram, what I will do, I'll draw my carbon at the center, right? Then I'll draw one chlorine here, one chlorine here, one chlorine here, one chlorine here, right? So this is Cl, 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 Cl. So remember, when you are drawing a dot and cross diagram, always draw or only draw the valence shell, right? So carbon has 4 electrons in its outer shell. So that's 1, 2, 3, 4, right? So I've drawn 4 carbons there. And in the case of the chlorine now, let's use a different color here. So in the case of the chlorine, you have 7. So let's start. 1, 2, 3, 4, 5, 6. And the 7th one will form the covalent bond here. Then again, you have 1, 2, 3, 4, 5, 6, 7, right? Again, 1, 2, 3, 4, 5, 6, 7. Then we have 1, 2, 3, 4, 5, 6, 7, right? So that's my dot and cross diagram here for my covalent compound, right? So I took carbon and I reacted it with chlorine to form CCl4. So this here is CCl4. That's a compound that we would have met in organic chem. That's why I chose that one, right? Right, let's see what we have here again. Right, an element X, not the actual symbol, has atomic number of 19. Place the element X in the correct position, right? So element X, so we have some element X here, and it has atomic number of 19, right? So they want to know where to put this element here. So if I were you, what I will do, I will first write the electronic configuration for this thing here. So this is going to be 2, 8, that's 10 electrons, 8, 2, 8, 8, that's 18, and I'm missing 1, right? Now, what that tells me, right, what that tells me is this. This compound here, or this element, right, this element belongs to period 4, because you have 4 shells. So it belongs to period 4, and it belongs to group 1, right? That information is based purely on this electronic configuration, right? So if we know it belongs to group 1, this is group 1 here, right? This here is actually period 3, and this here is period 4. So element X is going to be placed here, right? It belongs to group 1, period 4, right? So they can give you any atomic number and ask you or tell you to put it in a periodic table, right? Right, so let's see. Right, so some people asking questions about, now the exam is tomorrow. I don't know how much you're gonna learn for tomorrow, right? But I know a lot of people still studying. About 90% of the syllabus I have covered in my videos, right? So just look through the videos, and a lot of the answers to some of the questions you're all asking will be there, right? All right, I have a question here. A student produces ammonia in the lab by adding liquid Y to solid W and warming as shown. He uses damp blue litmus in seeking the identity of ammonia produced. So he's trying to produce ammonia. So what your syllabus says is that you need to know, how do I produce ammonia gas? So you need an ammonium salt. So the solid W here, what I will do, I will say that salt is ammonium chloride. This is on your syllabus, by the way, right? So that's an ammonium salt. You can use ammonium chloride. And liquid Y, we can use calcium hydroxide, right? So you need a base in order to create the ammonia gas, right? So calcium hydroxide, right? So that's, if you want to prepare ammonia gas, you need an ammonium salt and you need calcium hydroxide, or you need a base, right? So 2 marks for that. Identify the process by which ammonia gas that is produced at the bottom of the test tube comes in contact with the litmus, right? So you're producing the ammonia gas down here, right? But yet it reaching the litmus paper. What process are you talking about? How does that ammonia gas reach the litmus paper? How does that ammonia gas reach the litmus paper? Right? Somebody already said it. Diffusion, that's what they want, right? Diffusion. Right? Next part. Comment on the suitability of using moist litmus paper to identify ammonia gas. So all you need to say here is ammonia gas, right, is basic, right, and basic or alkaline substances turn blue. Wait, hold on, just now. I'm saying this wrong, right? So you want to test for ammonia gas, right? Now let me just make sure I have something clear with you guys here. So if you want to test for an acid, right? If you want to test for an acid, what happens is that blue litmus turns red. Right? So for an acid, blue litmus will turn red. Right? For a base, right, we need red litmus, right, and it will turn blue. Now, ammonia gas is alkaline, right? Ammonia gas is alkaline. So if you want to test for an alkaline substance, we need red litmus in order to do that, right? So it's alkaline and red litmus is needed, right? Not blue litmus. Red litmus is required. So there's a problem here. They use the wrong litmus in this quest, in the how they testing for this stuff, right? Right, so is it wrong color paper? So it says, so this color here, this blue is unsuitable, right? Next part 4. Instead of litmus test, describe one other test. So they want us to identify, or they want to test for ammonia gas, right? And write a balance equation. So if you want to test for ammonia gas here, right, all you need is to allow the gas, the Na3 gas, to come in contact with right, HCl fumes, right, HCl gas, right, and dense white fumes will be produced. Dense right? So when it comes to testing for ammonia gas, right? Some of you all may have done an experiment where you had these cotton balls, right, on two ends of a glass tube, right, and one end you had concentrated ammonia, right, so that's NH3 here, and we also had HCl, right, and what happens is that you get this white ring, right? So the equation that they want here is this: NH3 gas, right, plus HCl gas, right? What's going to happen is that they're going to combine and you're going to get NH4, that's ammonium chloride, right, solid, right? And that's the white fumes that we're going to get there, right? So this here is your dense white fumes, right? This is a confirmatory test to test for ammonia gas, right? Right? Yes, ammonia gas has a pungent smell, right? Has a pungent smell. Some properties of ammonia gas is very soluble in water, is less dense than air, right? Those are just some properties, right? Let's see what the time looking like here. Right? I'm going to do one more question with you guys here, right? One more question here, right? It's the only time I have with you guys actually. So electrolysis has many applications. The apparatus below in figure 1 can be used to purify copper by electrolysis, right? In order to adapt the electrolytic cell in figure 1 for the purification of copper, right, what material can be used as a cathode and the anode and the electrolyte? So let's start with the first one here. The cathode, what are we going to use for the cathode? This is purification of copper by electrolysis. What are we going to put as a cathode? Right, people saying pure copper, right? Pure copper, I agree. So this has to be pure copper. What about the anode? What are we going to put as the anode? This one. Right, people put impure copper. Yeah, it is impure copper. It is not just graphite, right? It's impure copper. Right, this is electrolytic purification of copper, right? So this is your positive terminal here, there's a negative terminal. So this here is your impure copper, right? And this here is your pure copper on this side, right? So thin sheet of pure copper on this side, right? And what electrolyte are we going to use here? What's the electrolyte that they use in this particular purification process? Right, now seeing some correct answers, right? So in this case here, it is copper 2 sulfate, right? So CuSO4 aqueous, right? So that's your electrolyte for this particular process. As electrolysis proceeds, describe the changes expected to be observed at the cathode and the anode. So remember, the cathode is this is where the pure copper is, right? So what's going to happen is that pure copper is going to be deposited. So the mass of the cathode will increase, right? Mass of cathode increases. Right? So that's what's going to happen here, right? At the anode now, right? Remember the anode is the impure copper, right? So the mass of anode decreases, right? But at the same time, you will notice something as well, right? The impurities deposit at the bottom. So the impurities deposit at the bottom. right? And then the electrolyte now, right? For the electrolyte, what's happening here? So in the case of the electrolyte, remember what's happening here is this. You have the impure, right? There's the impure copper here, right? And what's going to happen is this. So the Cu2 plus from the solution, right, is going to be deposited at the cathode here, right, as copper. At the same time, Cu2 plus is going to be produced from the solid block of copper that you have here, right, the impure block. So therefore, Cu2 plus is leaving the solution, but at the same time, it's being added back to the solution, right? So therefore, there is going to be no change in color, right? No change in color, right? Remember, the color of the solution is dependent on the Cu2 plus ions. So you're removing it, but at the same time, you put it in the back. So there's no change, right? Write half equations to show what's happening, right? So at the anode, let's start with the anode, or let's start with the cathode. So Cu2 plus, right, aqueous, right? We're going to add 2 electrons to this, and then you're going to get Cu solid, right? So this is what's happening at the cathode, right? So Cu2 plus is being deposited at the cathode. At the anode, right, what happens here is copper solid, right, turns into Cu2 plus, right, aqueous, plus 2 electrons. Right? That's the equation for what's happening at the anode. If you get an electrolysis question tomorrow, it is typically worth plenty marks to write down, right? To write down your half equations, right? So be careful with that, right? There are about 4 or 5 of them we have to know for the exam. That is aqueous sodium chloride. You have to learn concentrated sodium chloride. You have to learn molten lead 2 bromide. We have to learn, I think, dilute sulfuric acid, right? So make sure you know the various electrolysis that we need to know for the exam, right? Next part here, we have a calculation involving electrolysis. So 5 amperes is passed for 2 hours during the period of electrolysis. Could you all quickly work out part 1 for me? What is the quantity of electricity in coulombs? Alright, let's see what's happening here, right? So Q is equal to IT. If you can't work out anything in this question here, right, you should be able to work this out here. So the current is 5 amperes, and you're letting this run for 2 hours. So that's 2 hours multiplied by 60, convert to minutes, multiplied by next 60 to convert to seconds. Just remember, in this formula, we're working in seconds. So it's 5 by 2 by 60 by 60. And we're going to get 36,000 coulombs. Right? So that's the charge that passed in this 2 hours here. Right? We want to work out the mass of copper deposited. So if you want to do that, you need to look at the equation. So that's Cu2 plus, right, plus 2 electrons produces copper. Right? That's copper solid. Now, according to this equation here, what we need to figure out, we need to pay attention to this. Right? Now that is 2 moles of electrons produces 1 mole of copper. So we can say 2 Faradays, right, produces 1 mole copper. So what I'm going to do, I'm going to replace the Faradays with coulombs. So 2 by 96,500 coulombs will produce, and I'm going to replace the 1 mole of copper. I'm going to change that to mass 1 time. So that's going to be 64 grams copper. They gave us that in the question. That's here. That's these 2 numbers here. And what we're going to do now, we're going to work out how much or what mass is deposited based on the charge that actually flew. So the charge was 36,000. So we're just going to say 36,000 coulombs will produce. And again, I told you all cross multiply this number multiplied by this number divided by this number here. So that's going to be 3600 multiplied by 64 all over 2 by, I missed out a 6 here, 96,500. Right? When you work this out, this will give you the mass of copper deposited. So 3600 multiplied by 64 divided by 2 by right, and I'm getting about 1.19 grams copper. Right. And the last part here now, they said in addition to the extraction of metal from their compounds, electrolytic processes are also widely used to protect metals from corrosion as well as make them attractive. Right? Name 2 electrolytic processes. What are 2 that some of you all have covered in school or in my class, guys? What are 2 other electrolytic processes? They said they use them to protect metals from corrosion as well as make them attractive. What 2 are they talking about here? Right, that's all right, guys. Let me see. Hold on. Some people saying, oh, wait, my bad. Did I make a mistake? Back up a sec. 36,000. Right, hold on. Let's double check my answer first, guys. 4 by 2 by 60 by 60. Right, 36,000. Thanks for the correction. So this is 36,000. So that's going to affect my answer here. Right, so let's change this answer here. So it should be 11.9 then. Right, let's double check that. 11.9. Right, so I've seen people saying electroplating and what else? Right, let me see what else people have here. Right, so some people saying electroplating, anodizing. Yeah, those are the 2 that are required for the exam, right? So electroplating is 1, so you can make metals look better. So if you want to make a chain look like it's a gold chain, you can electroplate it, right? Another thing we can do to prevent corrosion is by anodizing. Right, so anodizing is on your syllabus, right? And we use anodizing in order to increase the oxide layer on aluminium, right? All right, guys, so that is it for me for tonight, right? Like I said, my exam preparation usually lasts 4 months, right? So this was just a last minute revision, right? Good luck in the exam tomorrow. Right, read your questions carefully. Right, read your questions carefully. Try to answer what is being asked. Try to give complete answers. Right. So I want to wish everybody good luck in the exam tomorrow. Take your time. Right, you can do this. Once you've done the work, then you should be able to manage. Right. Those of you who are still revising, make sure and you review organic chem. That's very important. Make sure you review organic chem. All right. All right, guys, so that's it for me. Take it easy. Good luck tomorrow, right? And I'll see you guys sometime, right? Later.